Hi and welcome to this video. In today's session we will try to host Zeebe on our own PC using Kubernetes and KIND. In order to achieve this, I've split the video into two general sections. So first of all, we'll take a look on all the tools which we are going to need to install, like Helm, kubectl, KIND and Docker. And in the section afterwards, we'll then create a cluster, install the Zeebe full Helm chart and forward some ports in order to access them. In the end, we will then simply access, operate and task lists in order to see that everything is just working fine. Great. So let's dive directly into the topic and start with the installation of the system components. The first tool which we are going to need is Docker, and therefore you can head to the commonly known website from Docker in order to get the right distribution for you. So you can either run it on Mac, on Windows or on Linux. So since I'm using Mac, we will simply download the Docker image for the MacBook with Intel chip. Great. So now let's download this first of all, and then we need to continue with the installation of KIND. KIND itself is a tool for running local Kubernetes clusters using Docker containers, or so-called nodes. And it was primarily designed for testing Kubernetes itself, but also is used for local development or continuous integration. Great. So let's see how we can install such kind of tool. And therefore there is a nice documentation, a quick start documentation from KIND, which simply elaborates on what is needed in order to install the tool. So as you can see right here, we can skip to the part where you can see all those nice commands. We can, for instance, use Homebrew in order to install it on our Mac, or to use some or various Linux commands in order to install it there. It also provides some kind of installation commands for Windows. So typically everybody should be able to work with KIND. Great. For our purpose, we'll just use this brew install KIND and take a look on how this will end. Great. So we can just open up our terminal and copy our command here, and there you will see that hopefully Homebrew will install KIND properly. So you can see it's updating itself first, and then everything should happen. As you can see, I've already installed KIND and it's properly up to date. So that's perfectly fine, and we can continue now with the installation of kubectl. Kubectl is a command line tool allowing you to execute commands against Kubernetes clusters. As you can see right here in the documentation from Kubernetes, you can install it on various platforms as well. So for the macOS installation for our Intel Silicon, we can simply execute multiple of these commands in order to install it properly. The easiest one is of course to simply install this with Homebrew. So I can just type in brew install kubectl and afterwards it should be perfectly fine. So let's try this out as well. After having opened up my terminal window, I can just copy the command into here and press enter. So you should be able to see now that kubectl or the Kubernetes CLI is already up to date since I've installed it previously, but typically it would now run a script in order to install our package right there. Cool. So now we can continue with the last tool which needs to be installed, and this would be Helm. Before we install Helm, let's take a look on what is actually Helm doing at all. So Helm would help you to manage your Kubernetes applications and let you define, install, upgrade rather complex ones. So you can easily say that Helm is kind of a package manager for Kubernetes. In order to install it, let's take a look on this documentation page right here. And there you can see right here, when working on macOS, we could also rely on brew, install, helm. And of course, there are various commands or possibilities for Windows or Linux. So for our purposes, we will once again use Homebrew in order to install it on our MacBook. Once again, I can open up a terminal window in order to paste the command in here and install Helm. As you can see, I also installed Helm previously and it's already up to date, so no need to fetch any further packages right here as well. Cool! After having done so, we installed all the necessary packages in order to now create a cluster and run Zeebe inside of it. In order to get started, we first of all need to boot up our locally installed Docker. And as you can see right here, after fresh installation, no containers should be running. I do have 0 created volumes and no images yet. So I'm starting on a clean Docker installation as well. Great. Nevertheless, we do not need to actually work with this kind of Docker UI. I simply will use it for demonstration purposes in order to display some created containers, images, and volumes. So without further ado, let's focus on the main application we'll be working with, and that's our terminal. If you want to follow this guide step by step, you could also open up the docs.camundai.io in order to follow this deployment guide right here as well. So you can just skip through the chapters and see what's necessary in order to simply run and install Zeebe and how it will later on look on your own machine. Great. So yeah, I will link this description down in the description, and feel free to just jump into here and of course use this as well. Great. So now I've opened up our terminal, and the first thing which we'll need to do is to create a cluster for our kind Kubernetes. And that's fairly easy because we can just enter kind create cluster, and then we can give it a name right in here. Having executed this command, as said, it will create a cluster, and now kind will simply operate and execute it. So yeah, ensuring there's a node image, so on and so forth, and we'll simply wait until this operation has finished. Great. Now kind has created our cluster Zeebe. And in order to just make sure that it exists, we can simply execute the command kind get clusters. And this returns a list of actual clusters which are installed in our, or which do exist in our environment. Besides, if you do have multiple, you could set a pointer to the right cluster using kubectl. So you could do something like kubectl config get context, and this will simply set the pointer to the kind -Zeebe cluster, which we do have created just now. Another thing which I like to show you is the view from Docker. So Docker shows you certain things. So first of all, you can see the Zeebe control plane right in here, which was created by kind. We can also see that we do have a new image right here, and typically, as you can see, there's a new volume which was created. So that's perfectly fine. And now we have created a cluster on our local environment running Kubernetes. So what's up next? And since we have now created a cluster, we can rely on Helm in order to simply add the Zeebe repository and to fetch all the Helm charts which are required for Zeebe. And that's also fairly easy to do. We need to execute 2 commands in our terminal. And that's first of all Helm repo add Zeebe. And we also need to provide some kind of URL, and that's https helm.camunda.io. And these kind of links or these informations can be retrieved from the documentation I've shown you previously. So I will execute the command, and as you can see, I've already added Zeebe as a repository of mine right here. Nevertheless, I'm not done yet because I need to update the repository. So each time the Helm charts have been updated in Zeebe, I need to simply execute a Helm repo update. And this will simply update all my repository. And there you can see, hey, we've got an update from Zeebe, from the Zeebe chart repository, and now I can start working with it. So I'm sure I do have the newest version from Zeebe available. Great. Having fetched my Helm charts, I now need to install them. And that's also not that difficult. So in order to do so, I execute Helm install. I do provide a name, so let's call it Zeebe self-managed. And I need to specify that I want to install the Zeebe full Helm chart, which contains, for instance, operate, task list, and of course our engine together with an Elasticsearch database. Great. Another thing which I do need to do is to simply attach some kind of YAML because I'm working on my local environment. You can find this YAML for kind values or the kind values YAML in the documentation as well. And I can easily attach it via zip and kind values YAML. And of course you need to make sure that this file is actually in the repository you're working in. Great. Executing this command should install Zeebe. Let's see. Hey, this looks great. So it seems that the cluster has installed, or that Zeebe has installed in our cluster, and now apparently it's called Zeebe self-managed Zeebe. Well, that's perfectly fine. Great. After having done so, we can just make sure that everything is booted up properly, and therefore we can use kubectl in order to get our pods, for instance. And there I can see that currently Elasticsearch is initializing, the container are going to be created, and our task list is already running. If I want to follow the status updates of my pods, I can simply execute kubectl get pods -w, and then I get updates as soon as some status of my pod is going to change. Great. Let's wait until everything is booted up and running. Cool. As you can see, now all our pods are up and running successfully. So you see the Elasticsearch master, the ingress controller, Zeebe, our gateway, operate, and task list. Besides, I've opened up 3 other terminal windows because we are now going to need those in order to forward the proper ports so they are accessible from our local environment. And we can do so via kubectl, and we do need to port forward, as you can see. and therefore we do need to simply forward Zeebe self-managed Zeebe, because that's the name you can see right up here, and for instance operate Helm, and we are going to forward to port 8080 from our port 80. So let's do so, and right there you can see we are forwarding those. And of course the same needs to be done with our task list Helm chart right here. So let's do so. So now we have forwarded the port 80 from our task list pod to port 9090 on our localhost environment. And last but not least, we can also forward the port or a port to our Zeebe in case we want to rely on the Zeebe CTL. So that's also a possibility we can provide while forwarding this port. So that's fairly similar as said. Kube CTL port forward SBC Zeebe self-managed Zeebe, and we do want to forward 26,500 to 26,500. Oh no, there is no port at 2,600, 20,600, goddamn. So therefore let's use this one. Cool, this should be the right one. Perfect. Great. Having done so, we should be now able to access operate. So let's open up localhost 8080, and you can see it directs me to Camunda operate, and I can easily log in with demo. And as you do see, this is a very empty installation of Zeebe, so there are currently 0 running instances in total. Great, after having successfully installed Camunda on our local machine inside of a Kubernetes cluster, we are finished with this video. Let me know if you do have further questions, or if you do want to know about other Camunda cloud related topics. Feel free to leave a comment or to subscribe, and I will definitively come back to this later on. For your information, we are also planning to release a video on how you actually install the Zeebe full Helm chart on your self-managed Google Cloud platform. So stay tuned. See you next time. Bye.